right, so as you see up there, there's the notes. We're starting our Unit 8 today. It's really not that bad. It's a pretty good beginning to this unit. It's pretty easy. It's going to build on a lot of Algebra 1 concepts, so you need to make sure you kind of start, getting your mindset into thinking about some of the stuff that you learned in Algebra 1. We're still going to do a lot of factoring, reducing, stuff like that. But it's really, I don't think it's overly difficult. Okay, so that's a good thing. Again, a rational expression is a ratio of two polynomial expressions. Okay, basically a division problem. That's the way you can look at it as well. Sure. Okay. A rational expression, it's undefined if you have a zero in the denominator, right? That's any number. That's not just a rational expression, that's any number. If you have a zero in the denominator, it's undefined. Okay? So that's how you got your vertical slopes and stuff like that when you're dealing with slopes back in Algebra 1. Okay? If it asks you to find the values or the factors that would make it equal to 0, you would just take that undefined, that stuff underneath there. We're going to do that today, but we're going to take that underneath there and set it equal to 0 to figure it out. Okay? All right, again, pretty simple. Nothing crazy yet. Okay, again, just not that you haven't figured this out all year. Make sure you're printing these out because we don't have time to wait to write all that wordy stuff down. Okay, one of the things you're going to see that keeps coming back over and over and over again is that factor, reduce, multiply. Factor, reduce, multiply. And you'll see what I'm talking about here in just a minute. The other thing you need to remember too is your factoring flow chart. So that way you don't have to go right into doing rooftop or something like that. We always follow the, find the greatest common factor. After you find the greatest common factor, then you determine does it have a number in front of the leading coefficient, the leading variable, that square value. If it does have a number, then you do the rooftop. It doesn't, you don't have to do the rooftop. You can go down and just drop your parentheses and so forth. Okay. Let's go ahead and get started with our examples. We're going to do a whole bunch of examples today. All right, so we're going to simplify 3y squared plus 21 divided by y plus 7 times y squared minus 9. So the first thing we need to do is factor. We need to factor what we can factor. Okay, what about the top there? Can we factor something out of the top? 3. Yeah, we can factor out a 3 at least. So then you end up with 3, okay, outside the parentheses, okay, and then what does that leave you with? Y squared plus 7, okay. Oh, I'm sorry. I forgot these notes were incorrect. No, the notes are fine, but this needs to be added. 21y. Sorry. That'll make it a lot easier. Excuse me. Okay, so now when I factor it out, I factor out what? 3y squared plus 3y, right? So then you end up with y plus 7. Okay? Over. Look at the bottom. We try to factor anything we can on the bottom. Can you factor anything out on the bottom of y plus 7? No, so that just stays y plus 7. Okay? What about y squared minus 9? What do you see there? Difference of squares, so what do you end up with? Y plus 3 is what I heard, and y minus 3. Okay? Can I factor anything else out there?
Why did you do that?
Well, I just factored. That's the difference of squares, right? So y squared minus 9, that's that whole a squared minus b squared. If you have a squared minus b squared, then you have a plus b times a minus b. That was a couple months ago, probably about a month and a half ago, 2 months ago. That just factors it quicker, rather than saying, okay, let's do the rooftop, or let's do quadratic equation, or let's do whatever. That's the easier way to factor. Okay. So again, that's difference of squares. Okay. You can't remember. Okay, now all we have to do, so now we factored, so that's taken care of. So let's reduce. Okay. And remember, when we reduce, you have to take whole factors. And what I mean by that is that you can't just say, okay, well, let me pull out this y and cancel it with this y, and this y and cancel it with this y. You have to take whole factors and cancel them out. If it's in the parentheses, you got to take the whole parentheses or none of the parentheses. Okay, so what can I factor out? Okay, the only thing I see there is what? Y plus 7, right? So that cancels and that cancels. Okay, what does that leave me with? Yeah, 3y over y plus 3 times y minus 3. Now, depending on what book you're using or depending on what the book thinks, okay, you will see that oftentimes redistributed. So like some books will distribute this y plus 3 times y minus 3. Okay, they'll do that, which is just the y squared minus 9, right? Some books will do that. Some won't, okay? You'll just have to, and again, because I know the next question is going to be, well, how do I know when to do it and how do I know when not to do it? It just depends on your answer choices, right? If you're doing a multiple choice test, if the answer choice is, this, then you go with that. If the answer choice is this with the y squared minus 9 underneath it, well, that's the answer, okay? Just FOIL it back out, okay? But ideally, to go along the lines of what we just talked about, we don't want to FOIL it back out. And so there's our answer. Now, that multiply part, which I didn't really stress it here, is that's what's happening here. We multiply here. Okay? So this is actually being multiplied. And again, if I continue to multiply it out, it would just give me the y squared minus 9, which doesn't make any sense to do that again twice. But if your book asks for it, then do what your book tells you to do. Okay? Okay, any questions on that? That's not going to happen a whole lot. I don't know about the textbook. I haven't looked at the textbook. Oh, I don't think so. Okay, and if it does, we'll look at it, but I don't think so. I'm not going to count it wrong, okay, because you did it or don't do it. All right? Okay. Let's look at our next example. Well, actually, the next example, excuse me, let me go back up there. The next example now says find what values, or for what values is the expression undefined. Okay, so if you remember what we had, we have to go back to the original equation here when we're using this. Okay, so when we go back to the original equation, we're looking at this again. Okay, and so what I'm looking at is the original denominator. And the original denominator, again, is y plus 7 times y squared minus 9. Now, somewhere I've got to find the values of that y that's going to make the denominator what? 0, right? Okay? So, with that being said, I can go back and factor it out again. That makes it easier. So if I go back and factor it out again, which we already did, we don't have to worry about the work. It's y plus 7 times y plus 3, y minus 3, right? So then what am I going to do with all those? Yeah, just that simple. Set them all equal to 0. So y plus 7 equals 0. Y plus 3 equals 0. And y minus 3 equals 0. So then the values that are going to make this equal to 0 on the bottom is going to be what?
-7, -3, and 3.
So y equals -7, y equals -3, and y equals +3. So those are your three values that will make that equal to 0 on the bottom. Once it's 0 on the bottom, that means you have a undefined situation there. Okay? But the key is to go back to the original denominator. Now this one was an easy one to go back to because we didn't really mess with it a whole lot. Okay? But we did take out the y plus 7, right? After we've solved it down. We've got to use that. That's got to be a factor in there. That's got to go back in there and account. Okay, any questions on that? Okay, pretty simple stuff. All right, let's look at our next example. Okay, here we're getting a little more longer as far as more to factor. Okay, so the first thing again we're sticking with the same rules as factor And if I, again, one of the things is write this down. Factor, then what? Reduce, and then what? Multiply. So if those are your rules to follow, then the first thing we want to do is factor. Okay? Now again, we just go through our factoring flow chart. What's the first thing that we can think of with factoring? Okay, is there a greatest common factor here on the top? No. So do I have a coefficient in front of the p squared? No. So I can start my factoring process by putting the parentheses, right? Okay, so we have to find values of what that equal what? You fill in those blanks. Tell me. Values of -3 that equal +2, which are what? Okay, so 3 and -1. So then you have p minus 3 times, p plus 3, excuse me, times p minus 3. 1. Whew. Okay, so p plus 3. So that nasty look up there looks like p plus 3 over p minus 1. Everybody agree with that? Okay, and again, we're not spending a lot of time on factoring. I just got done, we're starting our factoring unit in 9th grade, and I just got done telling them how it comes back a lot, right? You would agree with that. If you have freshman friends or know people that are freshmen, let them know. No matter whose class they're in, we're starting factoring right now, how important it is to really understand factoring, because this is probably, what, the 3rd or 4th unit we've used that we've had to factor something. So make sure they understand that. All right, let's look at the bottom now. Again, do we have a GCF? No. Okay. Do we have a coefficient in front of the p squared there? No. So we can start with our parentheses. Okay. So we're looking at factors of -15 that equal -2.
-5 and 3.
So p minus 5 and p plus 3. Okay. So now we factored. Can we factor any more? Can't do that. Now remember, you can't take a p out of every one. Remember, it's got to be whole factors. Right? So this ugly p plus 3 can go, and this p plus 3 can go. So what does that leave me with? P minus 1 over p minus 5. Now, is there anything for me to multiply? No. So we factored, we reduced. There's nothing for me to multiply. So, everybody agree that's my answer? Okay. Okay, just out of curiosity, if I wanted to know the values that made this denominator 0, it'd be what? P equals 5 and P equals -3, right? Remember, we set our factors of the original. Yeah, very good. Go back to the original. So you go back to the original denominator, well, that's this. You factor it out to this, okay? And then set it equals 0. So p minus 5 equals 0. That's going to give you a p is 5, right? And -3. It's only the bottom, right? Because remember, the undefined status is only when 0 is on the bottom. Okay? Any questions? All right. Let's move up to our next, or down to our next example. Okay. What's happening here? You're multiplying. You can do this a couple different ways. Okay? Say again? Okay, not necessarily cross multiply, but cross what? Because what are we trying to do? We're trying to, again, let's go back through this again. What are our three things? Factor, factor, reduce, and multiply, right? If I was going to multiply this period, I would go straight across, not cross multiply. But I can reduce by going across, right? Okay, so let's look at that first. And for some of you, and again, this is where your preference comes in. Okay, I'm not a big fan of cross reducing. I do it because it's quicker, but there's a lot of opportunity for mistake there because if you don't pay attention to put it in the right spot. But let's take a look. Does 8 go into 16? Yes. So I can get rid of 8, right? And it becomes what? 1. What does 16 become? 2. Okay? What about down here? What about the x's? I have common x's, right? So what's gonna happen here? This one's gonna cancel, and I'm gonna have how many left here? 2. So now I have 2x squared. Okay, over on the other side. What goes into what? 7, okay, goes away, and 21 becomes 3. Okay, I have y squared and y3. What's going to happen there?
3y and 1.
Okay, yeah, so y squared is going to go away. This y cubed is going to become y, or y to the first power, right? Okay, so now if I multiply what's left, I have 1 times 1, which is 1 over 3 times 2 is 6. Okay, y times x squared is x squared y. Got to go in alphabetical order. Yes, you do. Okay. Again, that is quicker. The only problem that I have with that is if, let's say you made a mistake and stuck that 3 up on the top of the 7 rather than on the bottom. That's going to mess you up. And it's not very organized, is it? It's hard to kind of see that work when you start, marking stuff out here and there. If you could do it, that's fine. But once you start making mistakes or making little errors, you need to stop. Because here's the other way to do this. Let's go back through. And let's just follow our original plan. Factor, reduce, and multiply. Okay, now, if I just go ahead and do what the problem tells me to do, which is multiply, 8 times 7 is what?
56xy squared.
Okay, so 56xy squared over... What's 21 times 16?
336.
Say again?
336.
So 336 x cubed, y cubed, right? Now, can I really factor monomials? Because these are called monomials. Can I factor those?
Yes.
No, I really can't. Okay, I can't. So you're like 0 for 5 today on your answers. Okay? So I really can't factor that, so we'll just check that, say we did it, because there's nothing you can do because it's a monomial. Can I reduce this, though?
Yes.
Absolutely. So let's reduce it. Okay, 56 divided by 336 is what? It's what the wonderful invention of a calculator gives you. Not 6, you did it backwards. Can't be 6, right? 1/6. If you do that, okay, and she made a common mistake that happens all the time, we want to divide 336 by 56. We want to do that, all right? Instinct tell us, hey, in elementary school, we were drilled and killed and told, divide the big number by the small number. We want to, and everybody makes that mistake from time to time. But you have to remember, if the small number is on top of the big number, you can still divide, but you're going to have a fraction. That 6 needs to be on the bottom. So then it becomes 1/6. So then I end up with, okay, 1 over 6. Now here, x divided by x to the third power is what? X squared. Okay, is it going to be top or bottom? Okay? It's going to be bottom. Why? The bigger's on the bottom. That's the easy shortcut. Bigger's on the bottom, you take it to the bottom as x squared positive. Otherwise, what I really have is x to the negative second power, right? Well, a negative second power is going to put me on the bottom. So it's positive. I don't ever want a negative power. So I'm going to have 6x squared. And then same thing, y squared divided by y to the third. It's going to be what? Y where? On the bottom, because again, the bigger one's on the bottom, right? Did we get the same answer? Yes. This one is just a little bit more neat, a little more organized, and you can actually see your thought process versus, I just canceled this out and canceled that out. It doesn't matter. I don't care which way you do it. Whichever way you're successful with is the key. You know, sometimes the long way is the better way. Again, one of the things, when you do math ever, there's always shortcuts. You know, one of the things that we do is, as I've taught special cases for multiplying polynomials, when you have 2x plus 3 squared, there's a special case, a shortcut you can do. Well, the thing about it is what do you know about the long way home? It always gets you where? Home, right? A shortcut usually has some kind of trick to it. Whether or not you you know, it's in the dark, it's a back road. Midlothian has a lot of shortcuts, are all back roads, but if you miss the wrong turn and you miss the exit, or, I mean, who knows, there could be a cow in the middle of the road, okay? It's no longer a shortcut, right? I mean, I used to come to school all the time going shortcuts. It just depends. It depends on the situation. You know, that's the key, but the long way always gets you there. The shortcut may trip you up here or there, so be careful. Definitely a train in Midlothian. Yeah. All right, any questions on that? All right, let's look at our next example. I want to show you some other examples that are a little bit different. What's happening in this problem right here? Now we're dividing, but what's happening? This is a rational expression divided by another rational expression, or a fraction divided by another fraction. So what does that really mean? I'm multiplying. So my first thing I need to do is change it to multiplication. Okay, so when I change it to multiplication, what is my new problem? Yeah, so does anything change with that first expression? No. Okay, I have 10 PS squared over 3C squared D. Don't be mad because you haven't answered any questions right today. Okay, times, that's because this isn't part of my 10. 6 C squared D squared over 5 PS. So we multiply by the reciprocal, right? We just flipped it. We took this from the denominator, put on the numerator, put the numerator on the denominator. All we did is flip it.
Why is the bottom not negative?
No, reciprocal isn't negative. Reciprocal is just a flip.
You just gotta be a man.
Okay, here's the deal. You got to remember back when, 6th grade probably, when you first learned about fractions. You cannot divide fractions. Yeah. You can't divide fractions, right? Back in 6th grade, what do they tell you to do? They say, hey, you can't divide a fraction because in 6th grade you weren't using the calculator, were you? Okay? You shouldn't have been using the calculator, right? Yeah. Okay, 6th grade you weren't using the calculator, say, hey, flip your reciprocal, flip that division problem, and then multiply straight across. So that's what we're doing here. Because a calculator is not going to save you here, is it? You have too many variables for a calculator to help you. Alright, so we just flip it, so we multiply. Please remember, when you flip it, the reciprocal has nothing to do with negative. Now, if you're talking about perpendicular lines, which is a whole different ballgame, that's a negative reciprocal you're dealing with there. Okay? So, all right, any questions? All right, let's move on. Okay, so now I need to go ahead, and again, either way will work. Which way do you want to do? You want to cross cancel, or do you want to do it the longer way? Huh? Short way, cross cancel? Everybody comfortable with that? Okay? If you need to, we can look at it later a different way. Okay, so let's cross cancel. Okay, how do we reduce the 10 PS? What does it become? 1. Okay, this is going to become 2, right? So you're going to have 2. Okay, what does 5 become? 1, right? But what is this? What about the P's? Okay, they cancel. Oops. Hang on, sorry. The P's are going to cancel because it's 1 and 1, right? So they're gone. Okay, what about over here? S squared and S. Where's the S going to be? On the top. So now you have 2S there. Okay, let's go look at the other side. What happens to the 6? It also turns into a 2. What happens to the 3? Turns into a 1. What about the C squares? What happens with them? They cancel because they're both C square. You're left with 1D. Where does it go? With the top. So now I have 2S times 2D, which gives me what? 4DS over 1, which simply reduces down to 4DS still. Still alphabetical order. Okay, and that's our answer. Okay, any questions on that? Okay, one thing I'm going to do differently, okay? Now, you have your videos of Miss Collins on my blackboard, right? I'm recording this to see if this will work. I'm going to try to put on YouTube tonight, okay? I'm going to try. I'm not going to guarantee. I'm still messing with this app. And what it'll be exactly our notes in our class. So you'll be able to hear Caleb.
You hear us talking?
Yeah.
Wait, we're recording right now?
Yeah. See. All right. So, moving on. All right. And the reason I wanted to show you that is so that way you can see the exact notes that we're taking. Okay, and what's happening in our class. All right, here we go. But I'll tell you, and I'll send you a Blackboard message if it works.
I don't get a Blackboard.
You have to put your email on Blackboard.
Yeah.
I put my email on Blackboard. I get it all the time.
Yeah.
Yeah, like your last class.
Oh, did you? All right. All right, here we go. So here's our next one. This is going to be a little different. What do I need to do first?
Simplify. Factor. Yeah, factor.
Okay, we're still factoring, right? So let's factor. Is there anything to factor with k minus 3 divided by k plus 1? Can I factor any of that? No. So it just comes down as k minus 3 divided by k plus 1. Okay, times. Okay, now that k squared, what is that still? Even though it's out of order, that 1 minus k squared, what does it still become?
Difference of squares.
It's still the difference of squares. What do you have?
K minus 1.
Don't switch it around. Keep it the same order. 1 minus k times 1 plus k. Okay, we haven't switched anything around yet. We'll do that in just a second.
See, I was getting this, but then the whole.
It's still the same thing. We haven't done anything different. Still the difference of squares. This just became your A,
Oh, so you just
and
factor
this
it.
became your B. Yeah, we're just factoring. That's all we do is factor it. Okay? Okay, what about factoring the bottom? Can I do a GCF there? No? Do I have a coefficient in front of the K squared? No. So we can just go ahead and do. So K minus 3 and K minus 1. Okay, now.
You can cancel out your K.
Yeah, the first thing I can do is I can cancel out what?
Your K minus 3 and then your 1 plus K.
Here's K minus 3 and K minus 3. That's cross-canceled, right? Now, here's the deal. What's wrong with these? Okay, I'm sorry, yeah, good point. What's wrong with these?
They're
That's negative in that case, positive.
Okay, so what do I need to do then?
Just cancel out.
does it matter?
Is it-
Okay, let's do this. Let's look at it this way. What if I changed it around? What if I said, okay, and I'm just looking at the top here. Now I have negative K, right? Plus 1.
Can't you times?
Hang on. And then K plus 1, right? Because addition is commutative, meaning I can move it around, whichever way I want to. Subtraction is not commutative, but what did I do here? I didn't make it subtraction, I made it what? I made it addition by keeping this negative, so I switched around. That's one thing I could do. Now, this helps because this now cancels out. And again, going back to this, that cancels that out, right? So now what I'm left with is what? Negative K plus 1 over K minus 1, right? Doesn't that kind of bother you that they look really close to the same?
Yeah.
Can I factor something out of one of these to make it the same?
Cancel out the.
Okay, she said I could factor. You can't cancel the ones because I can't take pieces of it. But she just said I could factor out a negative. So let's factor out a negative. If I factored out a negative, what does my top become? Negative 1 times. What's K, negative K divided by negative 1?
K.
Just K. What's 1 divided by negative 1? Negative 1. Over K minus 1. Can I cancel that out now? Yes. So what's my answer? Negative 1.
I don't think I have the ability to think about all this when I'm not sitting here talking to you about it. That's what I'm saying. When I'm home staring at my book and there's no.
But ideally, now here's the deal. Let me tell you this. Hey, and again, and this is not. All right, here we go. Again, let's go ahead and get started. What's the first thing you want to do here? Yeah, let's go ahead and flip it. Okay? You could go ahead and start factoring if you wanted to, but you know you're going to have to flip that second side. Okay? So, my new problem, I guess, is going to be 2d plus 6. That didn't change, right? D squared plus d minus 2 times now, instead of division, it's times d squared plus 3d plus 2 over d plus 3. Okay? Now we're going to go into what? Factoring. Okay? We're going to factor first, then reduce later. Okay? So what can I factor out of the first one? I can factor out a 2 there, and that's going to give me what? D plus 3. On the bottom. Okay, here I have, do I have a GCF on the bottom there?
Wait, where are you doing, where are you starting?
So here, I started with this one. So here's the new problem, right? And to give myself more room, I just came over here. So I factored out the 2 right here. Okay, and when I factored out that 2, it gave me d plus 3. Now I'm looking at this one right here, d squared plus d minus 2. Okay, so what do I factor out of d squared plus d minus 2? I don't have a GCF, so... Okay, so I have d plus 2. I guess I have to put the d there first. So d plus 2 over d minus 2. Everybody agree with that?
Minus 1.
Oh, minus 1. So good thing you don't agree with that. Okay. We still have our times. We haven't done anything to change that. What about the top over there? Okay, d plus 1 and d plus 2. Everybody agree with that? It's like, yeah, because I don't want to do the work. She did it already, so yes. I'm just kidding. I'm kidding. Okay, over d plus 3, right? Okay, we can go ahead and start cross-canceling, right? So what do you want to cross-cancel first? D plus 2 first? D plus 3? Okay. Can I cancel d minus 1 and d plus 1? No. Can I factor out a negative there? Will that do anything for me? No. Just stinks. It is what it is. Okay, so what do I have left on the top? 2d plus... Sorry, 2 times d plus 1. Because here's what I have left, right? I have 2 and d plus 1 left, right? And down on the bottom I have just d minus 1, right? So d minus 1.
Hey, where'd that highlighter come from?
Let's put it on there.
Why is there still a d plus 1?
Okay, hang on. I got 3 questions at one time. Okay, what is your question first?
Can you factor the 2 into the d plus 1?
Multiply it in, you mean? Yeah, you could multiply. Again, that's where it goes back to the book, or not the book, check your answer choices. You could multiply that back in. But ideally, because of what we're doing, we're trying to factor and reduce it down. Ideally, that you want to keep it pulled out. So this is kind of where you want to stop right there. Okay? This would be your answer, yes. You would be simplifying as far as possible. Now, what was your question, Ethan?
I figured it out.
Okay. All right. One more example.
That's all that you do on that?
That's it, yeah, we're done. Sure. One more example. Now,
This one looks kind of weird.
is this problem any different?
No, it's just stacked.
It's just stacked. Now, this is an awful way to write this, but it will happen. They will do stuff like that in order to trick you up, or whatever the case is. So, yeah, just rewrite it. Okay, how am I going to rewrite this? I'm going to move it up here. So, x squared. I keep forgetting to change it.
9x squared minus 4y.
Over 9x squared minus 4y squared.
And then it's 2y minus...
Okay, so I heard people wanting to go ahead and multiply, switch it. So then you have, when you divide, you do the reciprocal.
2y minus 3x
Over x cubed. Okay, so now we're ready to go, right? Okay. Let's go ahead and factor what we can factor. Okay? Over here, x squared can't be factored anymore, right? What about down here? What is this? It's the difference of squares again. So what do you end up with? Sorry, go ahead. 3x plus 2y, and then 3x minus 2y, right? Times, hopefully we can fit this in there. Can I factor anything out of the top? No, right? 2y minus 3x, right? Okay, over x cubed. Now, what are we looking at here again? Are we in another situation where we should switch it around? Okay, so let's take a look. Okay, what are we going to change that to? I'm going to do this. I'm going to come over here in a different color. I'm going to change the color a little bit. And let's take a look over here. What are we going to change this to? Sorry, I just pointed. Okay, so let's switch it around. We're going to do it over here. Negative 3x.
That's really hard to see.
Is it hard to see?
Yeah, is that like a lavender thing?
Lavender. I don't know. Okay, here we go.
Red.
How's that? It looks like it's black still. But anyhow, negative 3x. It won't be on the video. Negative 3x plus 2y. Now, does that help us with anything down here? Because ideally, this is up here, so we want to cross-cancel something here, right? Does that help us? So now I can factor out the negative again. So then I have negative 1 times 3x minus 2y. So I'm going to change this from 2y minus 3x to negative 1 times 3x minus 2y. Now let's start to cross-cancel. What?
Can you not just switch the 2y minus 3x and make it 3x minus 2y to be exactly like the 3x minus 2y on the bottom?
No, you have to have, you can't switch them that way because you're changing the values without factoring a negative in or out. You'd be changing the values without a purpose, basically. Okay, so now what can I cross-cancel? Okay, so the 3x minus 2y, let's go ahead and, we just did all that work, we might as well cancel them out, right? Okay, x squared, where does it go away? It reduces out, right? And then what happens down here? Turns x on the bottom, right? Okay, anything else I can do? So now you have to kind of weed through all this mess here and find out what we have left. So if you look here, we have a negative 1 left, right? We have this 3x plus 2y and this x left, right? So let's go ahead and write our answer out. What's on top? Negative 1 over or x times 3x plus 2y, right?
So is it not 3x squared?
You could, but again, we're kind of keeping it as simple as possible. Okay, again, if you multiplied it in there, it would be okay, I guess, technically, but we want to keep it as simple as possible, so we don't want to do that.
Money.
Okay, any questions on that?